Dear students, today we discuss some of the problems in microwave spectroscopy. So the first problem is how many revolutions per second does a carbon monoxide molecule can make when J is equal to 3. The carbon monoxide bond length is 0.1131 nanometer. Avogadro number and mu either you can calculate or mu is sometimes it will be given quantity. Usual well-known compounds, the atomic mass of such compounds you have to know. So in this case, we can see that R is given, the bond length R is given as R is equal to 0.1131 into 10 raised to minus 9 meter. So the reduced mass we can calculate mu is equal to mc mo divided by mc plus mo. So for carbon it is 12 and for oxygen it is 15. So 12 into 15 divided by 12 plus 15 then into Avogadro number. So that is a method for, one of the method for calculating the this reduced mass. So by calculating this you will get the mu as 1.1385 into 10 raised to minus 26 kilogram. Then I, the moment of inertia is given by I is equal to mu r square. So mu is also given and r is also given. R is given in the unit of nanometer, so it is 10 raised to minus 9 meter. So I is obtained as 0.1456 into 10 raised to minus 45 kilogram meter square. Now we have to find out how many revolutions this molecule can make when J is equal to 3. So the molecule rotational energy it is given by half I omega square, and which is equal to h square divided by 8 pi square I into j plus 1, or it is bhc into j plus 1. B ക്ക് നമുക്ക് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യാം, h divided by 8 pi square I c സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യാം, ഇൻറ്റു എച്ച് സി എന്ന് പറയുമ്പം h ഇൻറ്റു എച്ച് സ്ക്വയർ ആയിട്ട് മാറും. സോ ദിസ് വൺ ബിക്കംസ് BHC becomes h divided by 8 pi square IC into HC. So h into h square, c and c get cancelled. So h square divided by 8 pi square I into j plus 1. So from this we can calculate this omega, that is the angular frequency, which is equal to this. By solving this we will get it as h into root of j into j plus 1 divided by 2 pi I, that is half omega square. You can write it as 2 into h square divided by 8 pi square I into j plus 1 divided by into 2 divided by I. So this becomes I square. So root omega will be equal to omega, this 2 and 8 you can cancel, so that is equal to 4. So omega will be equal to root of this quantity. Root of this quantity will become h square into root h root of j into j plus 1 4 pi square I square into root 2 pi I എന്നുള്ള വാല്യൂ നമുക്ക് ഒബ്റ്റെയിൻ ചെയ്യും. So this angular frequency omega is 2 pi nu. Omega is equal to 2 pi nu. So nu we can calculate like this. This quantity whole divided by 2 pi. So by dividing with the 2 pi we will get it as 4 pi square I, h into root of j into j plus 1 4 pi square I. So new substituting all these quantities are given. This j is also given, j in the state 3. So by substituting this value 6.626 into 10 raised to minus 34 into root of 3 into 3 plus 1 divided by 4 pi square into 0.1456 into 10 raised to minus 45. So that is obtained as 39.93 into 10 raised to 10 hertz. So that is the revolutions per second, that is the frequency, that is the question. So frequency is obtained as 39.93 into 10 raised to 10 hertz. Now the next problem you can see the average spacing between successive rotational line of carbon monoxide is 3.8626 centimeter inverse. Determine the transition which gives the most intense spectral line at 300 K. So we have 2B is given as the spacing between rotational line is 2B. That is the difference separation between nearby lines otherwise not mentioned. If it is considered as a rigid rotator, the spacing is 2B. So 2b is given as 3.8626 centimeter inverse. So b will be divided by 2, so that is equal to 1.9313. Then the temperature is given as 300 Kelvin. Then we have to calculate for the most intense spectral line. The equation for the most intense spectral line J max is equal to root of KT divided by 2hCb minus half. So we can write like this: K, that is the Boltzmann's constant, and 0.381 into 10 raised to minus 23 into temperature 300 divided by 2 into, this is Planck's constant. Then C in the unit of, if B is in the unit of centimeter inverse, we have to substitute C in the unit of the centimeter per second. So 3 into 10 raised to 10 into 1.9313 minus half. So by taking the root of this one, we will get it as 7.3456 minus 0.5. So that value of J is obtained as 6.68456. So this is not, J value should be an integer. So the next, we have to take the value of J as the next higher value. That is for 6.8, it is the next J value is equal to 7. So the most intense line is obtained for J is equal to 7. Next problem is the J equal to 0 to 1 transition in HCl occurs at a 20.68 centimeter inverse. Regarding the molecule to be a rigid rotator, calculate the wavelength of the transition for J from 14 to 15. So 2b it is given as 20.68 centimeter inverse. So B is obtained as 10.34 centimeter inverse. Then we have to, the expression for transition of energy, that is the frequency or the wave number corresponding to a particular transition, is given by the expression 2b into j plus 1. For 0 to 1 transition, j equal to 0. So for the first transition, epsilon j is obtained as 2b, and so that is written like this: 2b equal to 20.68. So b is equal to 10.34 centimeter inverse. Now for the transition 14 to 15, we can substitute here for j as 14. So epsilon j is obtained as 2 into 10.34 into 14 plus 1. So that value is obtained as 310.2 centimeter inverse. Now we have to calculate the wavelength. This is the wave number and the reciprocal of which will give you the wavelength. So it is 1 by epsilon j. So that is equal to 1 by 310.2 centimeter inverse. So that value is obtained to be 32.10 raised to minus 4 centimeter, and it is obtained as 32 into 10 raised to minus 6 meter. And the next problem is the OH radical has a moment of inertia of 1.48 into 10 raised to minus 47 kilogram meter square. Calculate its internuclear distance. Also calculate for j equal to 5 its angular momentum and angular velocity. So moment of inertia is given. Moment of inertia I is given. So moment of inertia is nothing but mu r square. So mu, since it is OH radical, it is mHmo divided by mH plus mo. So for hydrogen, the atomic mass is 1. For oxygen, it is 16. So 1 into 16 divided by 1 plus 16 into Avogadro number. So 6.023 into 10 raised to 26. So actually here it is it should be 10 raised to 23. Then the value will be obtained in gram. So for obtaining the value in kilogram, you have to again multiply it with 10 raised to minus 3. So total you will get it as 10 raised to 26. So the value of mu will be obtained in the unit of kilogram. So that mu is obtained here 1.563 into 10 raised to minus 27 kilogram. Now we have using I is equal to mu r square. So r is equal to root of I by mu. So it is root of 1.48 into 10 raised to minus 47 divided by 1.563 into 10 raised to minus 27. So value of r is given as 9.731 into 10 raised to minus 11 meter. Then angular momentum, it is given by the expression. We have studied it. L is equal to h by 2 pi root of j into j plus 1. So L, h is, all these quantities are given. So it is equal to, here the j value is given as j is equal to 5. So substituting the value here, we will get the value of angular momentum as 5.77 into 10 raised to minus 34 joule second. Therefore L is nothing but I omega. L is equal to I omega. So angular velocity omega is given by L by I. So you can substitute the value here. L is 5.77 into 10 raised to minus 84 divided by 34 here. It is not 84, 34 divided by I is 1.48 into 10 raised to minus 47, and the value is obtained to be 3.9 into 10 raised to 13 radian per second. So this type of problems are usually asked in this chapter. Okay.